So silicon carbide is what's called the wideband technology. It's fundamentally a very fast technology. It has much smaller die sizes, and so you can build higher frequency converters, which makes the converter very small, which is important in automotive, for example. So it is a technology that has been there for some time, but it's now really taking off. It's not just the size, it is that it is very efficient. And efficiency translates to more range. So for the same size battery, you can go further, or you can make the battery smaller for the same range. And that incremental benefit in cost more than pays for the silicon carbide device. You know, we have had drivers for IGBTs for a long time, but IGBTs are a lot slower than silicon carbide. So when you start driving silicon carbide, you immediately run into multiple problems. One is you have to be able to drive it fast, which happens to be the least of the problems. Then you have to deal with all the noise you generate because you're running it fast, it switches so fast. But then the bigger problem is protecting the silicon carbide device. If there is a overload or a short circuit, IGBT can handle that for a long time. But the silicon carbide devices are so small, they're about 1/5 the die size, which means it has a very small thermal mass. And that translates directly to how fast you have to shut it down. You have to shut it down within 1/5 of the time. Now, you may think, well, so what's the big deal about it? Shut the whole thing down. The problem is if you shut it down too fast, it'll blow itself because of the voltages on the device will go very high very quickly. So you have to shut it down fast, but you also have to shut it down in a way that the voltage doesn't exceed the rating of the device. So we have to do that in a closed loop way. You monitor the voltage and shut down as fast as you can. And before you shut down, you also have to detect that you have to shut down. And that detection also has to be really fast. Unlike IGBTs, which you always use the same voltage, doesn't matter who makes the IGBT. It's always one voltage, positive and negative. But with silicon carbide, maybe because new technology, everybody makes it slightly differently. So they want different positive and negative voltages to turn it on and off, which means that your driver has to be able to adjust to that. Depending on whose MOSFET you're driving, you have to be able to program the voltage accordingly. And so we have to provide that feature. Well, obviously, when customers get excited about it, it's fantastic, but it's even better when our competitors tell us how good we are.